Hello everyone. In this video, we shall discuss about quadratic functions and its properties. What is a quadratic function? A quadratic function is a function of the form f of x equals a times x squared plus b times x plus c, where a is not equal to 0 and a, b, and c are real numbers. A is not 0 because if we have 0 times x squared, the function will be reduced to a linear function that is of the form b times x plus c. Now, the graph of a quadratic function is a parabola that is either opening upward or opening downward. Now, in order to determine whether the parabola opens upward or downward, it depends on the value of a. If a is positive, then the parabola is opening upward, while if A is negative, then the parabola is opening downward. Now, a quadratic function or the parabola has a special point which we call the vertex of the parabola. So if the parabola opens upward or when A is greater than 0, then the vertex is the lowest point of the graph. So as you can see in this parabola that opens upward, this is the vertex, which is the lowest point of the parabola. Now, if the parabola opens downward or when a is less than 0, then the vertex is the highest point of the graph. So in the second graph here, this is a parabola that opens downward, and the vertex here is the highest point on the parabola. So if we already know that the vertex is the lowest or the highest point, how do we get the coordinates of the vertex? So the coordinates of the vertex depend on the values of the coefficients of the terms of the quadratic expression. So it depends on A, B, and C. So the coordinates of the vertex will be denoted by h comma k, where h is computed using the formula negative of the value of b divided by 2 times a, while the y coordinate, which is k, is computed as the function value of the x coordinate of the vertex, which is also equal to 4 times a times c minus b squared divided by 4 times a. So for example, suppose that f of x is equal to negative x squared plus 8x minus 15. Is the parabola opening upward or downward? And compute for the coordinates of its vertex. So in this function, the value of a is negative 1, b is equal to 8, and c is equal to negative 15. Now, since a is negative 1, which is less than 0, then it means that the parabola is opening downward. Now, to compute for the coordinates of its vertex, the vertex is b with coordinates h comma k. Now, the formula for h is negative of b over 2 times a. And in this case, b is 8. So we have negative of 8 divided by 2 times a, which is negative 1, which is equal to negative 8 over negative 2. But since we have a double negative here, this is just 8 over 2, which is equal to 4. Now, to get the y coordinate of the vertex, then we just evaluate the given function f using the x coordinate of the vertex. So we have f of 4. So which means that we should substitute 4 to every occurrence of x in the given function. Hence, we have negative of the quantity of 4 squared plus 8 times 4 minus 15. Now to simplify this, we have negative of 4 squared, which is 16, and then plus 8 times 4 is 32, and then we have minus 15. So simplifying this, we get positive 1. So therefore, the vertex is V with coordinates h comma k, which is 4 comma 1. Next is the intercepts of a quadratic function. So how do we get the intercepts of a quadratic function? So given a quadratic function, f of x equals a times x squared plus b times x plus c, the intercepts can be computed as follows. So the x-intercept, we shall equate the function to 0. So that means we will be solving ax squared plus bx plus c equals 0, which is a quadratic equation. So this quadratic equation may be solved using either factoring or the quadratic formula. Now for the y-intercept, we shall evaluate the function f at x equals 0. So if we substitute 0 to every occurrence of x in the function, we will be getting y is equal to c. So therefore, the y-intercept has coordinates 0, comma c. Now we note that not all quadratic functions have x-intercepts. So for instance, if the parabola opens upward and the parabola is above the x-axis, then this parabola doesn't have an x-intercept. Now also, if the parabola opens downward and it is located below the x-axis, then this parabola also doesn't have an x-intercept. And these cases will only happen if d squared minus 4ac is less than 0. So let's have an example of finding the intercepts of a quadratic function. So consider again the function f of x equals negative x squared plus 8x minus 15. In the previous example, we found out that the vertex is 4, comma 1. Now, let us look for the intercepts of this quadratic function. So again, the for the x-intercept, we shall equate negative x squared plus 8x minus 15 to 0. And since the coefficient of x squared is negative, we can multiply both sides by negative 1. So we get positive x squared minus 8x plus 15 equals 0 times negative 1 is 0. So now this is in standard form where x squared has coefficient positive 1. So we can use factoring to solve this equation. And its factors would be x minus 3 times x minus 5. Equating both of these linear factors to 0 and solving for x, we will get x is equal to positive 3 and x is equal to positive 5. So therefore, the x-intercepts are 3, comma 0 and 5, comma 0. Now for the y-intercept, of course, we shall evaluate the function f using x equals 0. So that will be negative of 0 squared plus 8 times 0 minus 15. So this will give us 0 plus 0 minus 15, which is negative 15. So therefore, the y-intercept is the point 0, comma negative 15. So later on, if we want to graph this function, we shall use the vertex, the x-intercepts, and the y-intercept to graph the quadratic function. Now, a quadratic function also has a special line which we call the axis of symmetry. Now, the axis of symmetry of a quadratic function is a vertical line that passes through the vertex, and its equation is x is equal to h, where h is the x coordinate of the vertex. So if this is the vertex of the parabola, its coordinates is h comma k, then the line passing through that vertex has equation x is equal to h. And this serves as the axis of symmetry. So the axis of symmetry is a reflector line that mirror the points of the parabola. So for example, if this is the axis of symmetry and we have this point B on the parabola, then this point can be reflected along the axis of symmetry in order to generate another point on the parabola. So the distance of point B here with the axis of symmetry and the distance of point C with the axis of symmetry is for r equal. Now, how do we graph a quadratic function? So as I said earlier, to graph a quadratic function, we will be needing the special points like the vertex, the x-intercepts, the y-intercept. And first, you need to identify if the parabola is opening upward or downward. And then once you have the special points, we connect the points using a parabolic curve wherein the vertex is either the lowest or the highest point of the graph depending on the orientation of the parabola. So let's try graphing our example earlier. So again, if we consider f of x is equal to negative x squared plus 8x minus 15, let us sketch its graph. So from our previous examples, from our previous computations, so the vertex is 4, comma 1. So from the origin, we move 4 units to the right and then 1 unit upward. So we have 1, 2, 3, and 4, and then 1 unit upward. So we get this point as our vertex. Now also, in the previous example, we computed that the x-intercepts are the points 3, comma 0 and 5, comma 0. So from the origin, we move 3 units to the right. We get the first intercept, the first x-intercept. And then for 5, comma 0, from the origin, we move 5 units to the right to get the second x-intercept. And then we can also plot the y-intercept, which is 0, comma negative 15. So from the origin, we move 15 units downward. So that's why we have this point here as the y-intercept. So now connecting these points with a parabolic curve where the vertex is the highest point since this parabola is opening downward because a is negative 1, which is less than 0. So this graph here is the graph of negative x squared plus 8x minus 15. Okay, now, we can also use another technique in graphing quadratic functions. You may also use the axis of symmetry to graph a quadratic function. So first, we need to plot the vertex, and then we draw the axis of symmetry. So remember, the axis of symmetry is a line, is a vertical line that passes through the vertex. And then we plot another point of the parabola, and we can get this by substituting any value of x, and then we solve for the value of y. Now, in order to get this additional point here, we may opt to use the y-intercept. And then reflect the point that we obtained from this step using the axis of symmetry to get another point of the parabola. And then we connect those 3 points using a parabolic curve wherein the vertex is either the lowest or the highest point depending on the orientation of the parabola. Now, this technique helps when the vertex is the x-intercept or when the vertex is an x-intercept or when there are no x-intercepts for the quadratic function. So let's try to have an example for the following. Let us sketch the graph of f of x equals x squared minus 2x plus 2. So in here, the value of a is 1, the value of b is negative 2, and the value of c is positive 2. Now, since the value of a is 1, which is greater than 0, then it means that the parabola is opening upward. So to sketch the graph, we shall solve for the vertex h comma k, where h is equal to the negative of b over 2 times a. And in this case, it's going to be negative of negative 2 over 2 times 1. So it's going to be negative of negative 2 over positive 2. But since we have double negative here, this is going to be 2 over 2, which is positive 1. And then for the value of k, we can evaluate the function f using the x-coordinate of the vertex. So we have f of 1. So f of 1, we substitute 1 to every occurrence of x in the given function. So therefore, we get 1 squared minus 2 times 1 plus 2. And this gives us 1 minus 2 plus 2. So this is going to be 1. So which means that the vertex is the point 1 comma 1. Now for the x-intercept, we can equate x squared minus 2x plus 2 to 0 and solve for x. However, this expression is not factorable. So if not factorable, let's see if b squared minus 4ac is less than 0 to determine whether the parabola doesn't have an x-intercept. So the value of b squared minus 4ac would be negative 2 quantity squared minus 4 times 1 times 2. So again, we base it on these values. And negative 2 quantity squared is positive 4. And then 4 times 1 times 2 is 8. So we have 4 minus 8, which is negative 4. So since b squared minus 4ac is negative 4, that's less than 0, then that means the graph doesn't have an x-intercept. Now for the y-intercept, obviously, we're going to evaluate f0, and that's going to be the value of c, which is 2. So which means that the y-intercept is 0 comma 2. So since we have the vertex and then another point on the parabola, which is the y-intercept, we can plot the vertex, which is 1 comma 1, which is this point here. And then we plot the y-intercept, which is 0 comma 2, which is this point. And then since the distance of the y-intercept with the axis of symmetry is 1, then we have to reflect this point along the axis of symmetry to get the third point of the parabola. So again, this distance here is also 1. So connecting these 3 points here where the vertex is the lowest point, then that forms the graph of x squared minus 2x plus 2. And then finally, for the domain and range of a quadratic function, the domain of a quadratic function is the set of all real numbers, or the interval from negative infinity to positive infinity. That is because whenever we have a parabola opening down upward or a parabola that is opening downward, both of these graphs extend indefinitely in left side and in right side. So that's why the domain is the set of all real numbers. However, the range would depend on the orientation of the parabola. So the range will be from the x coordinate, from the y coordinate of the vertex going upward if the parabola opens upward. While if the parabola opens downward, then it's going to be negative infinity up to the y coordinate of the vertex. So mathematically, we write that as if the parabola opens upward, then the range would be the set of all y values such that y is greater than or equal to k. Otherwise, if parabola opens downward, the range would be the set of all y values such that y is less than or equal to k. And remember, this k here is the y coordinate of the vertex, which can be computed also using the formula 4ac minus b squared all over 4a. Okay, so let's have an example for the domain and range. So let's go back again to our first example earlier, wherein we have f of x is equal to negative x squared plus 8x minus 15. If you recall, its vertex is h comma k, which is 4 comma 1. So k is equal to 1. And since the parabola opens downward, then the range will be y is less than or equal to 1. And in symbols, it's going to be negative infinity up to 1, followed by a bracket. And then for our second example earlier, if we have the function f of x equal to x squared minus 2x plus 2, we found out earlier that the vertex is 1 comma 1. So again, for this example, k is equal to 1. And since the parabola opens upward, the range would be the set of all y such that y is greater than or equal to 1. Or in interval notation, we write that as bracket 1 comma infinity. So this ends our video about quadratic functions, and I hope that you learned something about its properties. And please do not forget to subscribe to my channel. Thank you for listening.